Hi everyone, this is Dr. Nak, and today we're going to be learning about graphing quadratic functions using properties. Let's first go with the definition of a quadratic function. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, c are real numbers and a cannot be 0. So if the a cannot be 0, you're given nothing but a second degree polynomial, but now we're going to have to view this as a function. The graph of a quadratic function will always have this U form. It could be looking upward or downward. Now, that graph is called a parabola. So when you graph a parabola, it's gonna look either one of those two here. The first one, the parabola opens upward, and the second one, it opens downward. To find out whether the parabola is gonna be opening upward or downward, you need to look at the leading coefficient. Leading coefficient is the number that's attached to your x squared. So if the leading coefficient a is positive, then the parabola will open upward. And if the leading coefficient is negative, then it is going to open downward. There are more definitions to a quadratic function. So what I did here is to find the lowest point on the parabola and also the highest point on the parabola, and then I just drew a straight line through it. So basically what I did was I drew a vertical line that divides the parabola into two equal halves. Now this line is called the axis of symmetry. Your axis of symmetry will always be a vertical line. So with that said, you should be able to write that in terms of an equation of a line. The equation of a vertical line can always be written as x equals a number. Now that number should be the x value where the vertical line is going straight through. So for the first graph, our equation for the axis of symmetry should be written as x equals, what's the x value where the line goes through? -2. So that will be the equation of the axis of symmetry for the first graph. Now for the second graph, the equation of the axis of symmetry, we can write that as x equals, what is that, -1? Because that's the value of x where the line goes straight down. Now let's talk about the very, very bottom point of the parabola and then very, very top point of the parabola. Now that point is called a vertex. So this is going to be the vertex. And for the parabola that's looking downward, the highest point will be the vertex of the parabola. So in this section, we're going to graph the quadratic function precisely by finding out the coordinates of the vertex, equation of the axis of symmetry, and the x-intercept and the y-intercept. So the next question should be, how can I find the axis of symmetry and the vertex of a parabola? Well, there is a formula for it. To graph f of x equals ax squared plus bx plus c, axis of symmetry is always going to be x equals -b over 2a. Now that x value is also going to be the x coordinate of the vertex. And the vertex formula is given by v equals -b over 2a and then f of -b over 2a. Now remember that vertex is a point. So this is nothing but your x coordinate, and f of -b over 2a is going to be the y coordinate of the vertex. Now let's go over how to graph a quadratic function using properties. Step number 1, determine if the parabola opens upward or downward. So let's recall that if the leading coefficient is positive, it is going to open upward, and if the leading coefficient is negative, it is going to open downward. Step 2, find the vertex. Now the formula for the vertex is x coordinate will be -b over 2a and the y coordinate will be f of -b over 2a. Step 3, find the axis of symmetry. The axis of symmetry is an equation of the line, so you better start out with x equals something. So the formula is x equals negative b over 2a. Now notice that that's nothing but the x-coordinate of the vertex. Step 4, find the x-intercept. How do you find the x-intercept? Well, given f of x equals ax squared plus bx plus c, all you have to do is set y equals to 0. Well, remember, y equals f of x, so basically what you need to do is set the whole equation equal to 0, and you just solve for x. Step 5, find the y-intercept. How do you find that? Is set x equals to 0, and then you just solve for y. And finally, step 6, we get to graph that parabola. I know there are a lot of things we need to do just to graph a parabola, but let's do it. First example, let's graph f of x equals 3x squared minus 6x plus 2. So here our a is 3, b is negative 6, and then c is going to be 2. Now let's follow step 1 through 6. So step number 1, we need to determine whether the parabola is going to be opening upward or downward. Well, that all depends on the value of a. So notice that a is 3, which is positive. That implies that it's going to open upward. Okay, so let me box that because this is important information. And step number 2, find the vertex. Okay, so the formula for that is negative b over 2a, and then f of negative b over 2a. Okay, so let's first compute negative b over 2a, and this is going to be the x-coordinate of the vertex. So here you're going to have negative 6, whole thing over 2 times 3. So this is positive 6 over 6. So it looks like our x-coordinate is going to be 1. So here we have 1 so far. Now to get the y-coordinate, we need to compute f of negative b over 2a. But negative b over 2a is 1. We just computed that. So we need to plug it in 1 in place of x into the original function to get 1 squared minus 6 times 1 and then plus 2. So which will give us 3 minus 6 plus 2. So that's going to give us 3 minus 6 is minus 3. Minus 3 plus 2 is minus 1. Okay, so that's going to be the y-coordinate of our vertex. Now let's go with step number 3. Let's write the equation for the axis of symmetry. Okay, so it's always going to be x equals the x-coordinate of your vertex, which is negative b over 2a. So here what we're going to get is x equals to 1. So that's the vertical line that's going to go through the vertex. Let's go with step number 4, find the x-intercept. Okay, how do you find that? Is set y equals to 0, and then you solve for x. So basically, y equals to f of x, so all you have to do is set the given function equals to 0. So here, what we need to do is 3x squared minus 6x plus 2 equals to 0, and then you need to solve for x. I don't think this factors, so what I'm going to do is apply the quadratic formula to solve for x. So let me just write down x equals to negative b plus or minus the square root of b squared minus 4ac, whole thing dividing by 2a. Alright, ready? So let's do this. So you got negative b, so we got b is negative 6, and then plus or minus the square root of b squared, so negative 6 whole quantity squared, minus 4ac, so 4 times 3 times 2, whole thing dividing by 2a, so 2 times 3. Okay, so then here what we're going to get is 6 plus or minus the square root of 36 minus 4 times 3 is 12. 12 times 2 is 24. Whole thing dividing by 6, which equals to 6 plus or minus the square root of 12. whole thing by 6. Now can I simplify 12 a little bit? Square root of 12 I meant. So this is what? 4 times 3, 2. So 12 is 2 squared times 3. So that means that square root of 12 is square root of 2 squared times 3, which gives us 2 square root of 3. That's a 3 inside of the radical, sorry. Alright, so let me rewrite. So this is going to give us 6 plus or minus 2 square root of 3 all over 6. Now separate. So we got 6 over 6 plus or minus 2 root 3 over 6. Always simplify. So this is going to give us 1 plus or minus. Now here I could cancel the 2 and a 6. 2 goes into 2 ones, into 6 how many? 3 times. So it looks like we're going to have square root of 3 over 3. Okay, so I know that square root of 3 over 3 is going to give us a decimal point. But anyways, let me just write down x-intercepts are when x is 1 plus square root of 3 over 3. Now remember, to find the x-intercept, remember we set the y equals to 0. So our y coordinate is going to be 0. And then another one is 1 minus square root of 3 over 3, comma, 0. So those are going to be our ugly x-intercepts. Alright, now step number 5, find the y-intercept. This might be a little bit easier. So how do you find it is you set x equals to 0 and then you solve for y. Okay, so our function was, let me just rewrite it at the top. We had f of x equals, what was our equation? F of x equals, what is 3x squared? And then minus 6x plus 2. Alright, so then if I set x equals to 0, then remember y equals to f of x, right? So we're going to have y equals 3 times the 0 squared minus 6 times 0 and then plus 2. So that's going to give us just 2. So therefore, y-intercept is going to be, at y-intercept, remember our x value is always going to be 0. So x coordinate is 0, and then the y coordinate is going to be positive 2. Alright, now, do we get to graph this? I hope so. Let's jot down what's important. So first of all, this parabola better open upward from step 1. Step 2, our vertex better be at 1, negative 1. And then axis of symmetry is x equals to 1. And this nasty x-intercept is going to be 1 plus the square root of 3 over 3, 0. And 1 minus square root of 3 over 3, 0. And the y-intercept is going to be 0, 2. Alright, so let's first plot those points. So keep in mind that this parabola better open upward, and the vertex is 1, negative 1. Always label your points, please. Okay, now the axis of symmetry is going to be at x equals to 1. Okay, so this is our axis of symmetry, x equals to 1. Now, the next one is the x-intercept. It's going to get a little nasty there because of the square root of 3 over 3. But let me first jot down the y-intercept then. So y-intercept is at 0, 2. So 0, 2. Okay, so 0, 2. Now, what's y-intercept graphically? That's where the graph is going to cross or touches the y-axis, and x-intercept is where the graph is going to cross or touches the x-axis. Now keep in mind that this parabola better open upward, and let's see, our vertex is at 1, negative 1, and the y-intercept is 0, 2. So the graph must cross at 0, 2. And since we have the axis of symmetry to be x equals to 1, remember, our graph is going to be symmetric with respect to that vertical line. So another point that we should plot will be right here. This point will be, what is that, 2, 2? Is that right? Okay, so now it looks like our graph is going to look something like this. That's not too bad. Pretend that's a nice parabola right there. But notice that, do you understand why I didn't plot that x-intercept? Because I knew that I was going to get a decimal value, but if I graph it out this way, then we already know that our x-intercept is going to be this point, these 2 points where the graph crosses the x-axis. Since the right-hand side of the x-intercept should be bigger than the one on the left, I would assume that the point on the right would be 1 plus square root of 3 over 3 comma 0, and the x-intercept on the left-hand side should be 1 minus the square root of 3 over 3 comma 0. Are we done? I think so. So we're done with one problem. Now, before we go on to the next example, do you guys remember this? The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac, whole thing dividing by 2a. And this quantity here, b squared minus 4ac, do you guys remember the name of that? This is called the discriminant. And if you remember what the discriminant tells you, do you remember that if the discriminant is positive, then you're going to have 2 real solutions. And if the discriminant is 0, then you're going to have 1 real solution. And if the discriminant is negative, then you're going to get an imaginary solution. So let me just spell that out again. So case 1 would be if the discriminant is positive. That implies that we're going to have 2 real solutions. Which means graphically what's going to happen is that our graph is going to cross the x-axis at 2 points. So what we're going to get is 2 x-intercepts. Okay, so in this case, let me just draw an example of it. So okay, so it could be looking upward or downward, it doesn't matter, but the point is that for sure we're going to have 2 x-intercepts. Now let's go with when the discriminant is 0. Remember, that means that we're going to have only 1 real solution, which means that we're only going to have 1 x-intercept. Okay, so let me draw that situation out. Okay, so since we're only going to have 1 x-intercept, right, our graph is going to touch the x-axis at 1 point only. So, which means that we're going to have a parabola either looking upward like this, just touching the x-axis at 1 point, or of course it could look down as well. Now let's do the third case. The third case is that if the discriminant is negative. So which means that we had 2 imaginary solutions, but the point is that we have imaginary solutions. Okay, now graphically that means that the parabola is not going to touch the x-axis anywhere. So what we're going to get is no x-intercept. Okay, so if I graph that out, situation out, what we're going to get is like a floating parabola. It's never going to touch the x-axis. And of course, it could look down as well, as long as it doesn't cross or touches the x-axis. So let me box what's important. So the discriminant is positive, 2 x-intercept. Discriminant is 0, only 1 x-intercept. And if the discriminant is negative, no x-intercept. Now let's take a look at example 2. Graph f of x equals negative 3x squared minus 6x plus 5. So what we're going to do is to follow those 6 steps that we did for example 1. So let's go with step number 1, but before I do that, let's determine our a's and b's and c's. So our a is -3, b is -6, and then c is 5. Okay, so step number 1, does the parabola open upward or downward? Well, our a is -3, which is negative, so that means that our parabola is going to open downward. So I'm just going to put down. So keep in mind that our graph better look something like this. Alright, so step number 2, I believe it was a vertex. The formula was -b/2a and then f of -b/2a. Okay, so let's first go with the -b/2a, which is the x-coordinate of our vertex. So here you're going to have negative, b is -6, whole thing over 2 times a, so which is 2 times -3, so we have 6 over, what is that? 6, just like that, -6, so it's going to give us -1. So right now what we got is -1. And now let's compute the y-coordinate of the vertex. So that will be f of -b/2a. So this is f of, well, -b/2a is -1. We just computed that. So now let's look at our function. I'm going to plug -1 in place of x. So you're going to have -3 times -1 whole quantity squared minus 6 times -1 and then plus 5, which is going to give us, well, -1 whole quantity squared is +1. Multiply that by -3, so you're going to have -3, and then you're going to have a plus 6 and then plus 5, which is going to give us already -3 plus 6 is 3. 3 plus 5 is 8. So it looks like our y-coordinate of the vertex is going to be 8. So we got vertex happening at -1, 8. And step number 3, it was axis of symmetry. Okay, so that's always going to be x equals the x-coordinate of the vertex, so which is -b/2a. So it looks like axis of symmetry is going to be x equals to -1. So let me box that. Alright, now what's next? Step 4 will be the x-intercept. Okay, so in order to do that, we're going to have to set f of x equals to 0 and solve for x. Okay, so I'm going to set the given function equal to 0. And we're going to solve for x from here. Now, let me remind myself what f of x was. So f of x was, what, -3x squared minus 6x plus 5. And we are at step number 4. So what do we want to do from here? Can we apply the quadratic formula? I think that's what I'm going to do. So let me just write down a is -3, b is -6, and then c is 5. Alright, quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, whole thing dividing by 2a. Okay, plug and chug. So this is going to be -b, so you're going to have -6 plus or minus the square root of -6 whole quantity squared minus 4 times the -3 times +5, whole entire thing dividing by 2 times a, which is 2 times -3. So here what do we get? 6 plus or minus the square root of 36, and then next sign is going to be plus, and looks like 4 times 3 is 12. Multiply that by 5, it's 60. Whole thing dividing by -6. Alright, so then here what we're going to get is 6 plus or minus the square root, is that 96? Whole thing dividing by -6. Now from here, can you tell how many x-intercept that we're going to get? Well, look at it. our discriminant is positive, isn't it? This guy is positive. So for sure, we're going to have 2 x-intercept. Just keep that in mind. All right, so now we're going to have to simplify square root of 96. So I'm just going to work it as a side work. 3 goes in, and then 32 times. And then 2 goes in, 16, 4, 4, 2, 2, and then 2, 2. So 96 looks like it's 3 times 2 to the, how many 2's we got? 1, 2, 3, 4, 5, 2 to the 5th. So since we're looking for perfect squared, we're going to have 3 times 2 times 2 to the 4th. So we have square root of 96 is going to be square root of 3 times 2, which is, I know that's 6, but at 2 to the 4th. So here, what we're going to get is square root of 2 to the 4th gives us 2 to the 2nd, which is 4. And then here you're going to have square root of 6. So let me try to rewrite that. Let me just bring it over here. So you got negative 6 plus or minus the 4 square root of 6, whole thing dividing by negative 6. Separate. So you got negative 6 over negative 6 plus or minus 4 over, just kidding, 4 times square root of 6 all over negative 6. Okay, so now here what we're going to get is 1 plus or minus, then here you're going to have, let's see, 2 goes into 4 twice, into 6 3 times. So it looks like what we have is 2 square root of 6 all over negative 3. Now notice that this negative 3, that negative number I should say, so if I multiply to that, you're going to have a negative. And if I multiply this negative to the bottom negative, you're going to have a positive. So regardless, here you're going to have 1, still you're going to have a plus or minus 2 root 6. Now it's all over 3. So it looks like our x-intercept is going to be, our x is 1 plus 2 square root of 6 over 3. Again, we're going to get some ugly decimal, comma, y value is always 0 at the x-intercept, and you're going to have 1 minus 2 square root of 6 all over 3, comma, 0. So I'm going to box that for our x-intercept. Now, step number 5, we're going to have to find that y-intercept. So what we need to do is set x equals to 0, and then you're going to have to solve for y. Okay, so we have y equals to negative 3 times 0 squared minus 6 times 0 plus 5. So it looks like what? That's going to be 5. So therefore, our y-intercept is going to be, well, x value is always going to be 0 at the y-intercept. So it looks like 0, 5 is going to be our y-intercept. Finally, step number 6, we're going to graph. Okay, so first of all, let me just jot down what we have as a summary. So step number 1, the parabola better be looking downward. And step number 2 was vertex. So our vertex was it negative 1, 8, I believe. And axis of symmetry is x equals to negative 1. And the ugly x-intercepts are 1 plus 2 square root of 6 over 3, 0, and 1 minus 2 square root of 6 over 3, 0. And the y-intercept was 0, 5. Okay, so first let me jot down the vertex, then the y-intercept, and then we'll deal with the x-intercept afterwards. So let's first jot down negative 1, 8. So we got negative 1, 1, 2, 3, 4, 5, 6, 7, 8. I think this is 8 right here, isn't it? So looks like this point is going to be our vertex. So we got negative 1, 8. Always label. Okay, and the y-intercept is at 0, 5. 1, 2, 3, 4, 5. Okay, so this should be 0, 5. Okay, now the axis of symmetry is at x equals to -1. So let me just draw a straight vertical line through x equals to -1. So this is going to be our axis of symmetry. Oop, that's a -1. Okay, now since the parabola better be symmetric with respect to the axis of symmetry, since our y-intercept is at 0, 5, then our graph better go through this point as well. Okay, so that's same thing as, what is that? -2, 5. Okay, so now our parabola better be looking downward, so our graph is gonna look something like, it's gonna go through here, then continues to go downward like this. Oh goodness, that looks like a V, but it's supposed to be curvy, and then it should be a parabola right there. But anyways, now let's deal with the x-intercepts. So the x-intercepts are where the graph's going to cross the x-axis, so that will be these 2 points. All right, now the right-hand side should be bigger, so the right-hand side of the x-intercept should be 1 plus 2 square root of 6 over 3, 0, and the 1 on the left should be 1 minus 2 square root of 6 over 3, 0. All right, I think we're done. Now let's just go, just for fun, let's just determine the maximum point. Where is the maximum point of this parabola? Well, that's nothing but at the vertex, isn't it? So the maximum point is going to be at -1, 8. Okay, now let's go to the word problem. Example 3. The quadratic equation h of t equals -16t squared plus 176t plus 4 models the height of a volleyball hit straight upwards with the velocity 176 feet per second from a height of 4 feet. Part A. How many seconds will it take the volleyball to reach its maximum height? And part B. Find the maximum height of the volleyball. Before we go over this, let's just understand what the heck is going on. So since we're given our h of t, which means h stands for the height and t usually stands for the time, so that you can read this as height at time t equals to -16t squared plus 176t plus 4. So don't get thrown off by the 176 and a 4. That's just an equation with the velocity of 176 feet per second and then the height of 4 feet. So when you graph that out, do you see that it's going to be a parabola looking downward because the leading coefficient's -16? So if I have to draw a picture, this is what's going on. Please do not be jealous of my drawing skills. But anyways, so the ball, you're going to start hitting the ball at the level of 4 feet, and the volleyball is going to go upward, and of course it has to come down sometimes. Now, the function that models this parabola is nothing but -16t squared plus 176t and then plus 4. Now, let's think about this a little bit. Let's go over part A. It says, how many seconds would it take the ball to reach its maximum height? So where is that maximum height? Isn't it nothing at a vertex? So this will be maximum height, which is the vertex. So let's first compute the vertex of that parabola. So the vertex formula was -b/2a, and then remember it was f of -b/2a, but our function is h. So we're going to have to say h of -b/2a. So before, this guy was the x coordinate, -b/2a, and this was the y coordinate. But now we have to view this a little bit differently because instead of variable x, we have t. So negative b over 2a, this is going to be our t. And since t is negative b over 2a, what we're computing for the height is height evaluated at t. So you're going to have to view this as t comma h of t. So what I'm trying to say is that instead of this axis being an x-axis, this is going to be the t-axis, and our y is going to be h of t. Alright, I think we're ready to do part A. It says how many seconds would it take for the ball to reach its maximum height? So basically what they're asking you to find is the x-coordinate of the vertex, because that's denoted by t. So let's do it. So our t is negative b over 2a, which is same thing as, oops, I forgot to write down who stands for a's and b's and c's. So here, let's see, a is negative 16, b is 176, and then c is 4. So our t is going to become negative b, so which is negative 176, over 2 times a, which is 2 times negative 16. So that will give us positive 176 over 32. If I divide that, what do we get? 5 and then 0.5. All right, so we got our t, which is in seconds, equaling to 5.5. So that's how many seconds a ball is going to reach the maximum height. So I'm going to write it as, therefore, the maximum height occurs at t equals to 5.5 seconds. Okay, so let me just box that for our official answer for part A. Oops, I forgot to write this as part A. Sorry about that. Now let's go with part B. Find the maximum height of the ball. Well, maximum height is attained at the vertex. So when t equals to 5.5, they're basically asking you what is the corresponding y value. So basically what they're asking you is to find h of 5.5. So let's do it. So h evaluated at 5.5, this is negative 16 times 5.5 squared plus 176 times 5.5, and then plus 4. Which is same thing as negative 16 times 5.5 squared is 30.25, and then plus 176 times 5.5, what the heck is that? 968, and then plus 4. All right, let's keep going. So let's multiply negative 16 times 30.25. So what is that? Negative 484. And then plus 968, and then plus 4. And negative 484 plus 968, that's 484. And then plus 4. So this is going to be 488. Phew. Okay, so basically at t equals to 5.5, the height of the volleyball is going to be at 488 feet. So if I regraph the situation out, then instead of the x-axis, we're going to have a t-axis. And at 5.5, when t equals to 5.5, our y value is going to be 488. So 488 is the maximum height. And then that occurs when t equals to 5.5. So I'm going to answer this problem as, therefore, after 5.5 seconds, the volleyball will reach its maximum height of 488 feet. And we're done. It is not as bad as you think All you have to do is understand what the heck was going on. I'm going to stop here, so if you have any questions, please let me know. Good job, everyone.